And now it's a hot mess. But that's because everything is temporary on the breadboard. So there's lots of wires coming out of there and going into it and coming out of it and everything. Got one H-bridge going, powers and motor, and a current sensor right here for the H-bridge, and a current sensor for the electronics, meaning everything over here. What else? Okay, hooked up to the motor with the wheel. My trusty dusty batteries. Yeah, and then we have over here, it's measuring, it's trying to run the motor, but I don't have the motor power connected. That's what this is for. But you can see that the electronics is drawing about 1.5 amps, which is pretty good. I'd like it to be a little bit lower, but I guess that's how much the microcontroller and the current sensors need to run. And then we've got the peak of each, and then the H-bridge, HBR, is the amperage on the H-bridge, which is a small negative value right now because it's around 0. Okay, so now what we do is we throw the master kill switch to on, and I'm gonna have to do this really quickly here because the motor will spin out of control. So here we go. Here's the wheel. Master kill switch. I hold it in my mouth. Oh, there we go. Starting up slow. Going up, up, 1.22 was the max draw from the motor because it's starting up and slowly accelerating to maximum speed. So it doesn't draw that much current because it's going so slowly. But this thing is tough. I tried to hold on to this wheel while it was running at high speed, which is only 75 revolutions per minute. I could not hold on to it. It was way too strong for me. Like, I could not hold on to this thing. So why don't we, I don't know what to do here. We have to throw the master kill switch. And I don't want to repeat my previous mistake of trying to, wait, here we go. I don't want to make my previous mistake again of allowing the motor to spin with the wheel touching the ground, and then it would wind up the coil around the motor. Anyways, it's running great. What will eventually happen is this circuitry will be duplicated onto this blue breadboard, or no, blue proto board underneath here. And then the green and green boards are for expansion to include 3 of these, which is a way to get analog to digital readings on a I2C bus. So basically I can have a whole bunch of thermistors, one on each battery, one on each motor, one on each H-bridge. So that's 2, 4, 6, 7, 8, 9. And then I have a 12, 13, 14, 9, 10, 11, 12, another 3 extra for other heat sensing. So the thermistor senses the heat and changes its resistance. The voltage is measured based on that. And that's how we get temperature readings, so we don't blow anything up. Okay, this is pretty cool. Ciao.